Hello, everybody. In Module 4, we discuss communication games between managers and market. Module 4 has 6 lessons. Today, we're focused on Lesson 5, costly misreporting models. In previous lessons, we're assuming either the lying costs are infinite or the lying costs are 0. In this class, we look at the intermediate case. Lying is costly, but the cost is certainly not infinite. We assume exogenous lying cost. In my opinion, endogenizing lying cost would make a significant contribution to the literature. As we're going to see very shortly, you allow the manager to lie does not necessarily mean that investors, they're always fooled from managers lying. The discussions in this lesson are based on Stein 1989 QJE and Fisher and Varicka 2000 accounting review. First, let's look at a simple model of costly misreporting based on Stein 1989. The manager observes the true value of the firm V privately. Investors do not know. The manager can choose to report some R that is different from V. Reporting R different from V incurs some lying cost. And the lying cost here is assumed to be some quadratic cost. The manager chooses how much to misreport to maximize the expected price conditional on the report minus the lying cost. Investors set the price equal to expected value of V conditional on the manager's report. And of course, investors are going to conjecture managers' misreporting strategy. Misreporting B is the endogenous, which means that investors are going to form some conjecture about how the manager is going to misreport. Investors is going to conjecture that the manager is going to misreport earnings upwards by some value B hat, which means that given this conjecture, investors are going to set price equal to the expected value of V conditional R to be R minus B hat. So B hat is positive. The manager has to take investors' pricing as given. So expectation of P conditional R would just be R minus B hat. The manager cannot change that. But the manager can choose B to affect R. Eventually, the manager's objective function is V plus B minus B hat minus 1/2 CB squared. First order condition with respect to B, you take B hat as given, as fixed. That results in B star equals 1/C. In equilibrium, the conjecture has to be consistent with the actual choice. That results in B hat equals B star equals 1/C. What are the implications? In equilibrium, there is no loss information content because investors can always perfectly infer V from R. Just subtract 1/C from R, you get the true value of V. However, because manager always reports upwards by 1/C, earnings management generates a deadweight cost. So in this case, managers, they're forced to misreport earnings upwards by 1/C. The reason is that investors, they would always conjecture that the manager is going to misreport upwards. So they're always going to subtract from the manager's report. So if the managers do not manipulate, they would consider to have been manipulated, but have lower fundamentals. So they're going to be even worse off. But in general, because investors are not fooled and manager incurs this deadweight earnings management cost, the managers are worse off from the ability to manage earnings. This does not seem to be consistent with empirical findings because empirically, investors are sometimes fooled and managers are not necessarily worse off from the ability to manage earnings. That means we need to change the model. How to make sure that investors sometimes are fooled and cannot completely back out managers' misreporting bias? Well, just add some other stuff that the investors also do not know. Fisher and Varicka makes such attempt. They introduce uncertainty about the manager's incentives. Instead of the manager's objective being expectation of P conditional R minus the lying cost in the simple misreporting framework, they assume that managers is going to maximize X times expected price conditional report minus lying cost. X is only known to the manager. In this way, investors do not know about X and do not know about V, so they cannot completely back out the reporting bias. What is the justification? The justification is sometimes managers may want a lower short-term price. For example, if you have stock options being issued to you in a short future, you may want stock prices to go down a little bit. But such compensation arrangement is not known by the investor. So investors are not completely sure to what extent managers want to maximize short-term price. we discussed a simplified version of Fisher and Verrecchia, which also ties closely to the simple misreporting model that we discussed previously. Let's assume firm value has a prior normal distribution with mean 0 and variance sigma v squared. Manager observes v, investors do not. This is their prior. The manager chooses the report to maximize the manager's objective function, which, as already discussed, is x times expected value of p, conditional on report R minus aligning cost. Investors, they do not observe x. Of course, they also have a prior knowledge of x. They assume that x is distributed normally with mean mu x and variance sigma x squared. We assume x is independent of v. And investors price the firm. The manager has to infer investors' pricing strategy, and investors have to infer manager's reporting strategy, because investors' pricing strategy is endogenous and manager's reporting strategy is endogenous. So for endogenous choices, you have to make inferences. The manager conjectures investors' pricing strategy and would take that as given and choose the misreporting, which is a function of v and x, two pieces of information that the manager knows about, to maximize the manager's objective function. The investors, they're going to form a conjecture about the manager's misreporting strategy. They're going to set a price equal to expected value of v, conditional on the report and conditional on the conjecture of the manager's misreporting strategy. In equilibrium, of course, the conjectures have to be consistent with the actual. So now let's solve for the equilibrium. Given the normal distribution, given risk neutral, all these nice assumptions, it would be good to focus on linear equilibrium, which means manager's reporting bias will be a linear function of v and x. And price is going to be a linear function of the report R. And for conjectures, you can just put a hat on this for conjectures. Given manager's conjecture about investors' pricing, manager chooses misreporting to maximize the manager's objective function. And we can solve for the first order condition to be this. And matching coefficients, that results in lambda v and delta equals 0. And lambda x would be equal to beta hat over c. So we have one equation between lambda x and beta, and we need another one. Another one comes from investor's pricing function. Given the conjecture of manager's misreporting, investors is going to set a price of R equals expected value of v, conditional R, conditional on the misreporting bias. And Bayesian updating is going to generate to this result. And matching coefficients, again, is going to give you another function for lambda x, this time lambda x hat, and beta. In equilibrium, the conjecture has to be the same as the actual, which means that all these hat would be equal to the actual choice. And therefore, we have an equation of beta. And solving for beta, we can get lambda x. And we can show that there is always going to be a unique solution beta between 0 and 1. And this beta can be interpreted as earnings response coefficient. In the extreme case, in the special case, when mu x equals 1 and sigma x squared equals 0, there is no uncertainty about manager's incentive. Manager is just going to maximize the expected price, conditional report minus line cost. Then we got beta equals 1 and b equals 1 over c. That's back to the fully revealing benchmark we discussed a few slides ago. Provide empirical implications, we look at comparative statics. First, higher marginal cost of earnings management increases ERC. And this is intuitive. Higher marginal cost of earnings management reduces earnings management. And when it reduces misreporting, investors are going to think the earnings signal is going to be more informative. They're going to put more weight on earnings signal. So ERC increases. The second result, more uncertainty about managers' short-term price incentives would decrease ERC. And the reason is there is more uncertainty about managers' short-term incentive. The informatives of earnings about the fundamental firm value decreases because the misreporting could be due to fundamental related reasons, or it could be due to managers' short-term pricing incentive related reasons. There's more uncertainty about the short-term price incentives. The informativeness of earnings infer about the fundamental value goes down. And this has been empirically verified by Ferry et al. 2018 JAE paper. The third comparative statistics, more prior uncertainty about firm value increases ERC. When there is more prior uncertainty about firm value, investors are going to put more weight on earnings report relative to the prior, and that further increases ERC. To conclude, in a pure costly misreporting framework with only information asymmetry about the firm value, but without other information asymmetry or uncertainty, you will have a fully revealing report because investors can fully back out the misreporting. It's kind of similar to the Grossman-Milgram results in verifiable disclosure framework. However, if you add information asymmetry about other dimensions, for example, uncertainty about the manager's short-term price incentives as in Fisher and Vareke, can not only result in the report not fully revealing, but also generate novel empirical implications regarding how earnings response coefficient varies with exogenous parameters. The report not fully revealing also allows us to study issues related to accounting, because if a report is fully revealing, there isn't really any accounting issues that we can study. For example, such information is subject to managerial manipulation. For this point, you can check Dai and Sridhar 2004 JAR paper. If you want to test your understanding of this class, a review quiz of this lesson can be found at the link on the slides. Thank you very much.